Hello guys, my name is Ali Mohammed Al Naqbi. I'm from 12th from IIT Fujia, and today I'm going to explain part 2 solar system from term 2 quiz project. Let's get started. Okay, so the elliptical orbit of Plato has the greatest eccentricity among all planets of our solar system, 0.248. Plato's orbit has the Sun at one focus and a major axis of 79.6 AU astronomical units. Consider Plato's orbit on a giant coordinate grid where x and y are measured in AU, and the Sun is at the origin, as shown in the figure above. So this is the figure. Okay, moving to question A. Use the length of the major axis to determine A. Okay, so back ago they told us that the major axis was 79.6. Okay, as we know from ellipse, major major is 2a. Okay, this means 79.6 equal 2a. Divide both sides by 2 and it will give us 39.8 for A. And this is how we solve for question 1. A. Let me erase that. Moving next. Use the eccentricity in A to determine the focal radius C, round to 2 decimal places. So in order to find the C, we have this equation, which is C equal EA, because we have E, which is the eccentricity. Okay, so C equal E, which is 0.248 times A, which is 39.8. So C equal 9.87 AU. This is the final answer for question B. Moving next. Next. Write an equation of the form x minus c squared over a squared plus y squared over b squared equal 1 to model Plato's orbit. Find b first. Okay. We have c, which is 9.87, and we have a, which is 39.8. What we need is to find b. In ellipse, we have an equation for all CAE, which is c squared equal a squared minus b squared. So C is 9.87 and A is 39. Oops, I mean squared, because squared, which is important. So, oh, my mistake. 9.8 squared minus B squared. So when we substitute, this will give us B squared equal 1486.62. Then we square root them, and this will give us B equal 38.56. Now we need to write an equation. So let me write the C. C is 9.87. Now C, okay. A is 39.8, and B is what is it again? 38.56. They want us to write in the form of this: x minus c squared over a squared minus y squared over b squared equal 1. So what we need is A, C, and B, which is those. I just split them. C is 9.87. C is 9.87. A is 39.6. Of course, 39.6 squared. 8. Of course, it's 39.8 squared. So when we square them, it will give us 1584.04. Also, same goes with B, which is square of 38.56. That is 1486.62. This is how we solve for question C, by finding B first, then write it in equation. Moving next, the apogee is when the Plato is closer to the sun. The apogee is, let me focus. The apogee is when it is furthest from the sun. What are the distance from the sun at this point? So we need the farthest distance and the nearest distance, which we call them apogee and perigee. Correct me if I pronounce it wrong. So for perigee, which is closest to the sun, G, which is far not farthest, farthest from sun. How we know that? Simple. So this is the graph. The perigee is when Plato is closer to the sun. The closest point is this point. And the apogee is when the Plato is farthest from the sun. So this is the farthest point. This and this. Mean. Hold on. G is A minus C, whereas apogee A plus C. So the distance from center to A is 39.8 minus the distance from 7. Okay, this will give us 29.93 AU. As for the apogee, which is furthest from the sun, 39.9 plus 9.87, which is, I think it's 49.67. So now going back, so the distance from the sun to the nearest is 29.93, and the distance from the sun to the farthest, which we call it apogee, is 49.67. And that's how we solve term 2 part 2 solar system question. Simple and easy. Goodbye.